Welcome back. This is going to be a video talking about rational exponents. So this follows on from the discussion of integer exponents, which was the last video. So if you haven't had a chance to look at that, go and take a look. And if you have a piece of paper and a pencil and you want to follow along, let's get right to it. So the word rational, in this case, just means, it's the adjective that goes with the word fraction. So rational is the same thing as fraction. And this is going to get a little bit full, so let's make this a little bit finer. That means something like, what is 4 to the power of 1/2? What is 7 to the power of 3/2? What is 9 to the power of -6/5? And do those things mean anything? So if you remember back last time, we put together a long list of laws that you can use, and by just being a little bit clever in the way we put together the laws, we can make sense of something in a way that makes sense, because these are laws, and when you have a law, you want to have a system that doesn't have any exceptions in it. So you want to have it be that all the rules you have work all the time. And that's what we're going to do. So we'll take the easy one, which is 4 to the power of 1/2. And at some point, somebody realized, they were writing down lots of numbers and lots of problems, that if we took two of them, 4 to the 1/2 times 4 to the 1/2, then this rule over here says that I have to add those two together. So this must be equal to 4 to the 1/2 plus 1/2. And if you thought that the handwriting was hard last time, now you have little itty baby fractions, little bitty baby fractions that you have to try and write up above normal size numbers. So it's really, really important that you have a nice sharp pencil. A mechanical pencil is really, really good. And then you can write really fine numbers and still be able to read what the heck you were writing 10 minutes ago. Anyway, this is 1/2 plus 1/2 is 4 to the power 1, which is 4. So cut that short. 4 to the power of 1/2 times 4 to the power of 1/2 equals 4. Now, I don't know what this number is, but you do what you do in math always when you don't know what a thing is, just give it a name. So this is some mystery number A times another mystery number A, and that is equal to 4, okay? Well, A times A is A squared is equal to 4, all right? That means, that means A is equal to the square root of 4, or 4 to the 1/2 is the square root of 4. So that's a general rule. I could have picked any number instead of 4, and the result would have been the same. So now you get another law, which is something to the power of 1/2 is just the square root of that something. Okay, so far so good. What now about, let's say, 8 to the power 1/3? Well, if it worked over here and there were two of them and 2 halves added up to 1, the same rule should work. I should write 3 of them. 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3. That has to be equal to 8 to the 1/3 plus 1/3 plus 1/3, which is equal to 8 to the 1, which is equal to 8. Okay? So now you have a number where 3 of them in a row multiply together, and they give 8. Now, you may not know off the top of your head what the name is for something where you multiply it 3 times together and you get 8. That is the cube root of 8. What we never really told you, because there wasn't reason to, is when you write just the regular square root symbol, there's actually an invisible 2 here. That's where the square in, so really this symbol is root, and it is called the radical sign. So this is the part that you call the root, and there's an invisible 2 there. So when I write this, this is the square root, this is the cube root, we run out of words, this is the 4th root, 5th root, and so on. And you have to look on your calculator, and there's probably a button that looks something like this, which is a square root sign, and there will be something here. So for example, this might be an X and this might be a Y, or this might not be here, it might just be an empty space, but there will be something that looks like a square root sign that will have an object in that space. And the way you would do in that case, say, the cube root of 8 on a calculator, is you would do the button for 3, then the button for mystery root, and then the button for 8, and then equals. And that would let you get the answer, because as you know, most of these things, the answer to most square root questions, most cube root questions, unless you pick your numbers very carefully, most of them are just ugly decimals that go on forever and ever and ever. It just so happens that in math textbook, they're very good at pulling out all the numbers where they're nice whole numbers, and they tend to make things easy for you. So now, that it handles all of the 1/2, 1/3, the 1 over something. So actually we'll go back over here and we'll just skip and we'll make that a rule. So a to the 1 over some number is the nth root of that number. So 7 to the 1 over 5 is just the 5th root of 7. 8 to the 1 over 8 is the 8th root of 8. And you might think that this is going to be something nice and fancy like 1 or 0 or 2, or it turns out not to work that way at all. If you plug this in on a calculator, you get something completely random and unrecognizable. What about 4 to the power of 2/3? Okay. Well, you can go back and be clever and use this rule backwards. 2/3 is 2 times 1/3. But to the power of 1/3 is a cube root, like that. Or I could have written it the other way. I could have done 1/3, times 2, which would have meant it was this part first, the cube root of 4 squared. And you could write that without the brackets and it would still mean the same thing. And this is an important result because it speeds through a lot of work, which is when you have something that looks like this, that has both a root and an exponent, it is exactly the same answer whether the exponent lives outside the radical sign or inside the radical sign. So we'll put all of that together. This is really a test of me learning Roman numerals more than anything else. So a to the something divided by something, that n is the nth root of a to the m, or, just as well, the nth root of a to the m. And which one you want depends on what the question is asking. And I will give you a quick rule for deciding which one is better right now. So let me take something that will actually have an answer. Let's do 27 to the 2/3. 27 to the power of 2 over 3. So I have two choices. I could put the 3 here and the 2 there, Or I could put the 3 there, oops, and the 2 there. Now this is going to take a lot of work because 27 squared, that I'm doing with a calculator. So this is going to be the cube root of 3 to some very, very large number. And then I will also have to get out a calculator to work out what the cube root of that is. However, the cube root of 3, and these you can just do by guess and check. You're going to be dealing with numbers that are something like 1s, 2s, 3s, and 4s to the power of something. So let's do cube root. 2 times 2 times 2 is 8. No, that's not right. 3 times 3 times 3 is 27. So yes, didn't need a calculator. You could do it basically with guess and check most of the time. So the cube root of 27 is 3 with a squared beside it, and 3 squared is 9. So the rule is, if you have a number underneath, then the version that is nicer is the version where the radical is here and the exponent is outside of the radical sign. The opposite is true if this is a letter, and all of these rules will still work if this is a letter. So if this is x to the power of 4 over 3, you will generally find that the question is easier to answer if you pick this one, cube root there, x there, and the 4 there. The other thing that's important to notice about this is that all the rules for fractions still work. So what is 2 to the power of 4 over 2? Well, that is the square root, and I don't have to write the 2, but if you're getting the hang of things and you want to write it, you may, and it will make things a little bit easier. And this is 2, and this is a number, so I'll put the 4 there. Now, that does not help me because let's actually change that. There. And I can do 2 to the power of 4 counting on my fingers. So 2 times 2 is 4, another times 2 is 8, and another times 4 is 16. So this is the square root of 16, and we do know the square root of 16. The square root of 16 is 4. But look over here at the fraction 4 over 2. 4 divided by 2 is just 2. This is 2 squared, and that is also equal to 4. So everything that you could do with a fraction, you can add fractions, you can multiply them, you can divide them, and all of it still works. So this really should not be 4 over 2. This really should just be 2. You see a fraction that you can reduce, you reduce it. And that goes through, so all of these original exponent rules are still valid. So if I take, and I'm going to switch to using letters, just because it doesn't matter if I use letters or numbers. So x to the power of 4 times x to the power of 2/3. That has to be equal to x to the 4 plus 2/3. And this works the same way. Okay, this is 4 over 1 plus 2 over 3. And if you have a calculator that can handle fractions and you just want to do fractions with your calculator, that's fine. So I would have to do times 3 times 3. This is 12 over 3 plus 2 over 3, which is 14 over 3. So this is x to the 14 over 3. And that's that. How about y to the 2/3 divided by y to the 5/6? That has to be, it's the subtraction rule, y to the 2 over 3 minus 5 over 6. And again, the same thing. You have to figure out what this is. So 2/3 minus 5/6. I should multiply that by 2. And by 2, I will get a common denominator, which is 4/6 minus 5/6, which is equal to -1/6, which means this is equal to y to the -1/6. And the same rule as before, a negative exponent is just 1 over, but I keep the same number. And this rule about not leaving a negative in your final answer, that still stands. But now you have a choice. Sometimes you might find it more useful to have this be y to the power of 1/6, and sometimes you might decide that this is better to have the 6th root of y. And which one of those you prefer is entirely up to you. We're going to stop this here and work on a few more advanced things to do with this in another video coming up soon. But for now, I will just leave you with that list of exponent laws. Have them nearby, have them handy, and good luck trying the questions. If there's questions in the comments or something else you'd like me to cover, leave it there. And hopefully we'll see another one of these very soon.